Welcome to Boring Stuff. Tonight, let your mind drift into a calm journey through one of the universe's simplest but strangest mysteries. Why light, the thing that lets us see everything, has a speed limit at all. We'll wander through ancient questions, quiet experiments, and the wonders of time and space, all in a soft, slow story to help you fall asleep. Long before you close your eyes tonight, there's a small scene I'd like you to imagine. It's simple enough to drift along the edges of your thoughts without keeping you awake. Picture a single beam of light, nothing more than a slender thread of brightness stretching through the vast, quiet dark. It slips silently from a tiny lamp on an old wooden table, or maybe from a lonely star out there in the farthest part of the night sky. However you see it, hold on to it gently in your mind. This small beam is the hero of our sleepy journey tonight. Now, see it glide forward, as if the universe itself is holding its breath to watch it go. There are no barriers in its path, no raindrops or dusty clouds, no wandering planets or busy satellites. Just empty, endless space that seems ready to swallow every color whole. But light is persistent, always moving, never resting, and never slowing down, though it doesn't speed up either. It goes exactly as fast as it must, no more and no less. And that's the first small wonder. Why should anything in this wide universe have a limit to how fast it can fly? It's an odd thing to ponder when you're curled under a blanket, listening to the soft tick of a clock or the hum of the night beyond your window. We're used to limits we can feel. Cars can't go faster than their engines allow. Runners grow tired. Cheetahs run out of breath. But light isn't alive the way we are. It doesn't eat or sleep or grow old. It just moves. Yet even this tireless traveler obeys an invisible rule. No matter what, it can never go faster than about 299,000 kilometers every second. If it tried to race beyond that, it would find that there is simply nowhere left to run. Somewhere in the back of your mind, you might wonder who decided on that number. Was it written in the stars before the stars themselves were born? Did the universe choose it the way an artist chooses a brushstroke, deliberate and meaningful? Or is it just another piece of the cosmic puzzle, sitting there so naturally that we forget to be amazed by it? Tonight, you don't need to solve this mystery. You just need to feel how strange and beautiful it is that the tiniest ray of light, leaving the surface of your bedside lamp, can travel so fast that if you could ride it, you'd circle the earth 7 times in just 1 second. 7 times around the oceans, over mountains, through sleepy towns and forests hushed by moonlight, before you could even blink. Yet it cannot push past that speed. It is forever loyal to its limit. In the old days, people didn't know light could be measured like this. They thought it was instant, like a thought or a heartbeat. It seemed impossible that a candle's glow or the sunlight warming a stone wall could be doing something so extraordinary, racing through the air, across empty distances, obeying a silent rule. But that beam you're picturing now, it has always known. Every spark that ever left a burning log in an ancient campfire knew too. The limit was there, waiting to be discovered by curious minds. So our beam glides forward, unwavering, unbothered by the shadows it leaves behind. If you imagine it leaving your lamp and shooting across your room, it will bounce softly off the walls, slip through a window pane, rise into the night sky, and continue into the darkness beyond. If you follow it far enough, you'd drift past the rustle of your neighborhood, past the rooftops dotted with chimneys and antennas, beyond the city lights, the sleepy fields, the gentle hum of highways, the planes cruising miles above. Eventually, you'd be so high that even the atmosphere would fall away behind you, and you'd find yourself coasting beside your little beam in pure, unbroken black. And still, it keeps its speed. Never more, never less. Out here, among drifting comets and frozen moons, the beam seems tiny, but its loyalty to its speed limit makes it as grand as the galaxies it may one day illuminate. It will travel for years, centuries, even eons, until it touches something willing to catch it. A distant planet, an astronaut's visor, the lens of a curious telescope peering back at Earth. And in all that time, it will never once question its limit. This constant speed is not a burden for light. It is simply the way light is, the way a river flows downhill, or the way a bird rides the air. In our busy minds, we sometimes wish we could break our limits, run faster, fly higher, think beyond what we know. But for our calm little beam, there is no need for more. Its speed is perfect for its nature, perfect for the dance it performs with space and time. What makes this even more soothing to think about is that light's speed shapes the entire universe. It sets the pace for how we see stars, for how we measure distance, for how time itself can bend and stretch under its influence. It's more than just a number scribbled in a physics textbook. It is a heartbeat that every galaxy follows, whether we're watching or not. So tonight, as you rest your eyes, imagine the glow slipping out into the dark. Let your thoughts drift alongside it. See the endless black not as empty or cold, but as a welcoming canvas for this single, steady traveler. It does not fear the dark. It does not hurry. It does not break its promise to the laws that keep it steady. And maybe, just maybe, as you drift off, you can imagine yourself as a tiny passenger riding along that beam, weightless, effortless, safe inside a thread of light that will never lose its way. With every heartbeat, you glide through the fabric of space, never needing to go faster than you already are. Somewhere, in this quiet place between thoughts and sleep, that beam will keep moving long after you have let it go. It will remind you, gently, that some limits are not prisons, but part of a grand design. They keep the world understandable, the stars in place, and the universe stitched together in a way that lets us dream. So keep this soft beam with you as you breathe slower, and as your mind grows still. Let it stretch out ahead, a delicate line connecting your cozy bed to the farthest star. No rush, no race. Just the beautiful certainty that light, with all its speed and softness, knows exactly how far to go and how fast to get there. If you keep drifting along with that gentle beam, you'll find yourself moving backward in time too, like tracing the light from a distant star all the way to the beginning of its journey. Long before modern telescopes or satellites, long before anyone measured the speed of light with numbers and clocks, people looked at flickering flames and shimmering stars and wondered what they were really seeing. Imagine an ancient night, thousands of years ago. The world is quieter, darker, less cluttered by the hum of machines. Somewhere, a small campfire burns on a hilltop. The flames crackle and dance, throwing sparks into the air like tiny fireflies escaping into the black. Around the fire, a few figures huddle under rough blankets, their faces lit by the soft glow. Maybe they are shepherds, watching over their flocks. Maybe they are travelers, resting on a long road. Or maybe they are just people, exactly like you and me, staring into the light and letting their minds wander. It's easy to forget that the questions that keep us awake at night have always been here, circling the warmth of a flame or the glow of the moon. What is light? Does it live inside the wood until it's freed by fire? Does it shine from the stars forever, or does it fade away when no one is looking? And the most curious question of all, how does it get from there to here? Is it an instant magic trick, or does it move through the dark like an invisible traveler, taking its time? Somewhere in ancient Greece, a man named Empedocles sat with these questions. He was a philosopher and a poet, living in a world where the boundaries between science and myth blurred into each other like dawn melting into day. He thought deeply about the sun's rays and the glint of stars on the ocean's surface. He wondered if light didn't just appear the moment we opened our eyes, but if it had to move, like a runner crossing the stadium floor. If so, then maybe light was not infinite in its swiftness. Maybe it had a journey to make. In Empedocles' mind, light was not a gift from the gods alone. It was a real thing with a path and a pace, slipping from place to place. His idea was remarkable, considering how impossible it would have been to prove with the tools he had. He had no precise clocks, no lenses to magnify the distant heavens. Only his thoughts and the quiet conversations shared by firelight. A century or so later, another Greek thinker named Aristotle looked up at the same stars and felt differently. He found it hard to believe that light could have a speed at all. To him, light was too immediate, too sudden. When the sun rose, darkness vanished instantly. When a lantern was lit, the shadows recoiled at once. If light needed time to move, shouldn't there be a delay, some moment when the darkness and brightness wrestled with each other? But there was none. And so Aristotle declared that light moved instantaneously, faster than anything could ever hope to follow. And for a long time, people believed him. Imagine that. For centuries, the wisest scholars accepted that light did not travel, but appeared in a blink. That idea sat unchallenged in quiet libraries, scribbled into parchment and whispered in ancient classrooms. Meanwhile, the world kept shining, every sunrise and candle flame obeying its true speed, regardless of whether anyone understood. Far from the cities of marble and scrolls, ordinary people had their own ways of thinking about light. Some saw it as a flame passed between torches, a spark from one soul to another. Others told stories of the sun god pulling a golden chariot across the sky, flinging beams like ribbons to warm the earth below. They didn't need to know how fast those ribbons flew. It was enough that they did, and that each day ended in sunset and darkness, only to begin again. Back then, light was not so much a thing to measure as a companion in the dark. It guided sailors home, flickered in hearths, glowed in lanterns swinging on city walls. In those early days, the greatest wonder was not how fast light moved, but that it could move at all, bridging the gap between the stars and the eyes of those who wished upon them. Centuries rolled by, and the old questions dozed like embers waiting for the wind. Empires rose and fell, fires burned in castles and cottages, and always that faithful beam of light traveled at its steadfast pace, unnoticed by those who relied on its warmth and glow. Sometimes a curious mind would stir the coals of the old debate. In the golden age of Islamic science, scholars like Alhazen sat in dim chambers with polished mirrors and glass spheres, wondering how light bent, reflected, and spread through the air. They crafted experiments in dusty rooms, peering at sunbeams slipping through pinholes in curtains. They saw that light behaved in strange, measurable ways. Yet even then, the exact speed remained a ghost, suspected but always out of reach. It would take many more centuries, and the stubbornness of stargazers, to prove what Empedocles had only guessed. But before the telescopes and the ticking gears of precise clocks, there was simply the hush of wondering. A patient, almost dreamlike wondering that drifted from generation to generation, tucked into scrolls and stories, prayers and poems. There is something soothing about this part of the story. To think that long ago, in places without electricity, people fell asleep by candlelight with the same questions we whisper to ourselves now. They didn't know about photons or the dance between energy and mass. They only knew that light was precious. It chased away monsters in the shadows. It promised dawn after long, cold nights, and it connected distant fires, distant stars, distant souls. So tonight, as you rest under your blankets, remember that you are part of this quiet lineage. Your tiny beam, slipping across your ceiling or slipping through your mind, is the same ancient mystery that flickered in a shepherd's eyes or flickered on a philosopher's parchment. It has always moved, sometimes as a wisp of flame, sometimes as a silver moonbeam, sometimes as the brilliance of the sun cresting over old stone walls. Though we have learned so much more about light than Empedocles or Aristotle could ever dream, the heart of the question remains as gentle as it was back then. How does something so small, so bright, know exactly how fast to travel? And what other secrets might it hold, just waiting for us to notice? So hold that thought like an ember glowing softly in your mind. Let it warm you as you drift further back, deeper into the story of how we finally found a way to measure the immeasurable. And somewhere, out there in the star-pricked darkness, that single beam keeps moving at its perfect, constant pace, never faster than it needs to be, yet always fast enough to light the way for those who dare to look. The little beam we've been drifting alongside has crossed centuries now, slipping through the minds of philosophers and the hands of poets. It has flickered in temples and palaces, over scrolls inked with guesses about how it might move. But for the longest time, no one could truly see light's secret journey. It was like trying to catch the wind with your bare hands, or weigh the warmth of a smile. People trusted that it was there, that it did its work. But how fast it did that work remained hidden in the hush between the stars. Yet curiosity is patient. It waits for the right minds, the right nights, the right tools. And sometimes all it takes is a man with a lantern and a hill. Imagine a young Galileo Galilei standing on a dark Italian hillside, cold breeze rustling his cloak, eyes squinting into the distance. His mind was busy with questions that made other people laugh or shake their heads. But he didn't mind the doubt. He wanted to know whether light truly traveled instantly, as Aristotle had said, or if it needed time, just the tiniest fraction of a heartbeat, to reach from one place to another. The story goes that Galileo and an assistant carried small shuttered lanterns up two neighboring hills, not too far apart, but far enough to test the moment when darkness turned to glow. Galileo would uncover his lantern, letting its beam escape into the night. The moment his assistant saw that glimmer, he would uncover his lantern too, sending his own beam back across the valley. If light were truly infinite in its speed, Galileo thought, then he would see his helper's lantern the very instant he opened his own. But if light needed time, even the smallest slip of it, there might be a delay, a heartbeat of darkness before the distant hill bloomed with fire. Standing there in the damp grass, straining his eyes across the night, Galileo waited. Lantern open, darkness broken, but his experiment betrayed him. No delay he could measure. Light, at such a short distance, seemed too quick for his eyes and his primitive clocks. In his notes, he wrote that if light did have a speed, it must be extraordinarily fast. He could not catch it with shutters and hillsides alone. Still, that quiet test left an ember burning for future dreamers. If you could find the right distance, the right clock, maybe you could measure the immeasurable. Decades turned into centuries once again. The little beam kept moving, slipping through windows of curiosity in minds all across Europe. Then came a young Danish astronomer named Ole Romer, who looked for answers not on lonely hillsides, but in the vast dance of Jupiter's moons. Romer spent long, cold nights peering through a telescope, watching tiny points of light orbit around the giant planet. One moon in particular, Io, would slip behind Jupiter and reappear like clockwork. But sometimes it would appear a little earlier than expected, sometimes a little later. Romer noticed a pattern. When Earth was moving closer to Jupiter, Io showed up early. When Earth was moving away, Io lagged behind. Most people might have blamed faulty observations or cloudy skies, but Romer saw something else. What if the delay was not Io changing its dance, but light itself taking more or less time to reach Earth, depending on the distance? He imagined the vast gulf of space as a sea the beam had to cross. When the sea was wide, the beam needed more time. When the sea was narrow, it arrived sooner. In 1676, Romer dared to say what no one had truly proven before. Light did not travel instantly. It had a speed, a real, finite speed. He even made a rough calculation. His numbers were not perfect by modern standards, but they were close enough to open a doorway. He showed the world that the old certainty of Aristotle had a crack in it. Light's secret was out. Imagine that moment, how quietly profound it must have been. No fireworks, no headlines on parchment. Just an astronomer with tired eyes, a candle sputtering on his desk, the hush of a Danish night pressing against the window. A moon, a telescope, and a mind willing to trust what the numbers whispered. The beam we follow kept moving, but now it had a name for its pace. The centuries that followed brought better telescopes, clearer glass, sharper minds. James Bradley watched how starlight seemed to shift as Earth orbited the sun, another clue that light traveled with a steady stride. Later, Fizeau and Foucault built clever machines of mirrors and wheels, bouncing beams down long corridors and catching their reflections like butterflies in a net. They measured delays so small they seemed impossible to detect. Fractions of a second, moments thinner than a breath. But they did it. Each flicker, each reflection, chipped away at the darkness of not knowing. By the mid-1800s, people finally had a good idea of just how fast that tiny beam moved, around 300,000 kilometers every second. Faster than any horse or cannonball or train. Faster than the planets themselves swirl around the sun. A number so vast it seems almost meaningless in our everyday world. And yet, it defines so much of what we see and feel. It sets the tempo for sunsets, the twinkle of distant stars, the pulse of signals bouncing from satellites to your phone. It shapes the very rhythm of the universe. Somewhere along the way, the little beam became more than just a thing to light our fires or guide our ships home. It became a messenger, a way to measure distances too big to cross with footsteps alone. The distance to the moon, to Mars, to the edges of the known universe, all counted in light's loyal steps. A light year is just the distance our tiny beam travels in one Earth year. A number so huge it humbles the restless mind and calms it too. Light gives us a way to hold the infinite in our hands, to see far-off galaxies as they were long before our world even formed. Tonight, as you drift closer to sleep, imagine Galileo's lantern on that quiet hill. Imagine Romer's weary eyes at his telescope. Imagine the slow, careful spin of mirrors catching that beam and sending it back again, echoing through dusty laboratories. So much patience, so much wonder, all for one small truth. Light moves. It moves at a pace that never changes, never cheats, never tires. And it's still moving now, out your window, through the night sky, past trees and rooftops, bouncing off the moon, slipping past planets, carrying secrets from ancient stars to your waiting eyes. Every flicker is a promise kept, a promise that the universe has its own rhythm, its own rules, and a limit that even light cannot break. So let your thoughts drift with that steady beam. Let it remind you that curiosity, like light, never truly stops. It keeps moving forward, patient and bright, carrying questions from the past into your dreams, ready to illuminate whatever dark corners you wish to explore when you wake again. When you follow the beam past Galileo's lanterns and Romer's moonlit observations, you come to a moment when the puzzle of light's speed found its final shape, the precise number we still whisper about today, even if we rarely pause to feel how strange it is. Somewhere in the quiet hum of the 19th century, experimenters turned their attention to perfecting this measurement. Mirrors spun on gears, beams bounced between distant points, and delicate lenses caught reflections that flickered for just a heartbeat before they slipped away again. They were chasing something so fast that it seemed to mock the tick-tock of even the finest clockwork. But they did not give up. One of these patient souls was Albert Michelson, who spent year after year refining his mirrors and wheels until he could measure tiny differences in light's arrival. Imagine him standing in long tunnels lined with polished glass, adjusting screws by the dim glow of oil lamps. Every time his beam returned to its source, he could catch it. A brief hello from light to its observer. By the end of his life, the number had settled into a shape that modern minds could hold on to. About 299.7 every second. A figure so precise that it feels more like poetry than arithmetic. Imagine saying that to yourself, half asleep. 299,792 kilometers every second. In that tiny sliver of time it takes to snap your fingers, light has already circled our entire Earth 7 times over. It's a number that is not just beautiful, but vital. It anchors our measurements, defines the distances between stars, sets the boundaries for how fast anything, matter, energy, information, can travel. It's as though the universe decided long ago that there should be a cosmic speed limit, something that holds the chaos in place and gives us something constant to trust. There's comfort in that constancy. The speed of light isn't just a physical property, like the weight of a rock or the warmth of a flame. It's woven into the very fabric of time and space. It whispers to black holes how to bend the world around them, tells particles how to behave in the smallest corners of reality. It governs the timing of satellites circling high above your house, making sure your phone can find you no matter where you stand. Sometimes, when you're lying in bed, it's easy to forget how deep this number runs. It's hidden behind every glow you see. The sunlight drifting through your curtains, the soft beam from your bedside lamp, the faint twinkle of stars so far away that they might have burned out before their last light ever reached you. But each photon, each piece of that traveling glow, is loyal to the same limit. It does not rush. It does not slow down. It simply obeys a rule older than any clock. And so our beam carries its number with it like a secret that shapes reality, holds the stars where they belong, and gives your eyes a glimpse into the distant past whenever you gaze up at the night sky. Now, drift a little deeper. It's time to look closer at this beam itself, to ask what light really is. For centuries, people thought of light as something simple, a wave, a particle, a glow in the dark. But the closer scientists peered, the stranger it became. Picture a pond on a windless day. You toss in a pebble, and ripples spread outward in perfect circles. Light, people thought, must be like those ripples, a wave spreading through some invisible medium. For a long time, they even gave this hidden sea a name, the luminiferous ether, an invisible substance filling all of space, allowing light to ride its gentle waves. But the experiments kept saying no. No matter how they searched, they could not find this ghostly ether. Light did not need a medium like water or air. It could glide through the perfect emptiness of space without losing its speed, without needing anything to carry it along. So they looked again, deeper, and found that light was not just a wave, but something else entirely. Sometimes it behaved like tiny particles, packets of energy that leapt from place to place in discrete steps, little quanta of brightness called photons. Each photon is born from a change, an electron jumping from one state to another, a spark dancing along a filament, a star fusing hydrogen into helium. When that change happens, a photon sets off on its journey at exactly the speed limit the universe allows. No warm-up, no acceleration. It is simply there, racing through the void, carrying energy from one point to another. Sometimes it travels for mere millimeters, from your lamp to your book. Other times, it crosses billions of light years, whispering the story of galaxies that vanished before Earth was more than dust. It's easy to think that something so fundamental would be simple to grasp. But light never behaves the way you expect. It can bend around corners when it passes through tiny slits. It can interfere with itself, like ripples overlapping on a pond. It can act like a wave and a particle at the same time, defying the boundaries of ordinary logic. Imagine, for a moment, being a photon. You are born from a spark in a star or the glow of an old bulb. In an instant, you leap into the emptiness, moving always at the same speed, never faster, never slower. You do not have mass the way an apple or a person does. You are pure energy, moving through a fabric that stretches and curves around you. This is the strange magic of our small beam. It is a messenger that defies easy explanations. A particle that acts like a wave that becomes a particle when you look at it closely enough. A traveler that rides the rules of the universe while quietly shaping those rules in return. Tonight, if you find your thoughts drifting to worries or noise, you can always return to this tiny wonder. A single beam of light, loyal to its speed, carrying its secrets across space and time. Neither wave nor particle alone, but both, shifting its nature depending on how you choose to look. And the best part? It does all this so gently, so persistently, that you never have to ask permission to enjoy its glow. The beam slips from the sun to your face, from your lamp to your pillow, from distant galaxies to the back of your eye, always keeping its promise, to move at the limit the universe allows, and never a fraction more. So as you breathe slower, let that beam keep you company. Let it remind you that even the simplest things, a flicker, a glimmer, a glow, can hold mysteries deeper than sleep, older than stars, and more constant than any dream. The light knows what it is. It knows how fast to go. And it keeps going, long after your eyes have closed and your thoughts have drifted far from here. Somewhere in the quiet hum of the early 20th century, while the world bustled with trains and telegraphs and the promise of new machines, one young mind was drifting in its own peculiar orbit. Picture a small room in Bern, Switzerland. A young patent clerk named Albert Einstein leans over his desk, sorting through pages of inventions and technical descriptions, his eyes drifting now and then to the window where sunlight slips across the cobblestone streets below. In that beam of light, his thoughts wander far beyond patents and paperwork. He has no grand laboratory, no team of assistants, no piles of gleaming equipment. Just a desk, a pen, and a mind that refuses to accept the ordinary answers. He begins to imagine, the way children do when they let themselves dream without limits. What would happen, he wonders, if you could chase a beam of light? Not with a horse or a train, but with your own mind, riding alongside that beam as it cuts through space. He lets this thought carry him. If you could somehow travel next to light, keeping pace with it stride for stride, what would you see? Would the light wave freeze beside you, like a frozen ripple on a pond? But this doesn't make sense. The laws of physics, as they were known at the time, said that light must always move at its special speed, no matter what. So how could you ever catch up? That simple question, so quiet, so dreamy, began to untangle the world's old ideas about how space and time behave. Before Einstein, people imagined time as a steady, universal heartbeat, ticking away the same for everyone, everywhere, like a giant clock hanging over the universe. They imagined space as a rigid stage on which all the actors, Stars, planets, light beams performed their dance. But the stubborn little beam of light didn't fit that picture. It refused to budge from its limit. No matter how fast you moved, it didn't slow down to let you catch up. This odd fact meant something profound. Maybe the problem wasn't with the light, but with the stage itself. Maybe time and space were not so rigid after all. So, with his pen scratching across blank pages late into the night, Einstein began to see a new picture unfold. In this new vision, the speed of light was more than just a number. It was a cosmic rule that kept everything balanced. To protect that limit, the universe would bend the very fabric of reality. Time could stretch or shrink. Space could expand or contract, all to ensure that no matter who you were or how fast you moved, you would always measure the same speed for that beam of light. Imagine that for a moment, lying warm under your blankets. You set off on a train speeding through the night, faster and faster, until it's moving at nearly the speed of light. The stars blur outside your window, the moon drifts behind you. Inside the train, your clock ticks away normally, your heart beats, you sip your tea. But to someone watching from the platform, your time has slowed down. Your heartbeat drifts in slow motion. Your teacup tilts in a dreamlike pour. The universe bends time itself to protect that tiny beam's speed limit. It seems impossible at first, like a bedtime fable meant only to puzzle the mind. But it's true. The faster you move, the more time slows down for you. Space itself changes shape, shrinking in the direction you're traveling. These are not just clever thoughts scribbled in a notebook. They've been tested again and again, proven by clocks on speeding jets, by particles racing through massive colliders, by GPS satellites whispering to our phones from high above Earth. What makes this so comforting, in a strange way, is that the speed of light becomes an anchor. No matter how wild or restless the universe might be, there is something that does not change. Even when time stretches and space curves, the little beam glides along at its constant pace, unbothered by the shifting scenery. It is the measure that all other measures bend to protect. Einstein's insight did more than change how scientists think about the cosmos. It changed how we think about ourselves. It revealed that space and time are not separate things, but woven together into a single, fluid fabric, space-time. And through that fabric, light stitches a path, setting the ultimate limit on how quickly information, matter, and energy can travel. Think of it like an endless cosmic quilt. Each star, each planet, each glimmer of light from your lamp or the moon overhead is a stitch holding the fabric together. The speed limit is what keeps the threads from fraying, what stops reality from unraveling into chaos. Sometimes people imagine what might happen if we could break this limit, if we could outrun the beam, travel faster than light, skip across the universe in an instant. But the deeper you drift into Einstein's dream, the more you see how strange and impossible that would be. To move faster than light would mean twisting time itself in knots, scrambling cause and effect, undoing the gentle flow that keeps the world understandable. So tonight, as you drift further into sleep, remember the young patent clerk at his desk, staring into a sunbeam and daring to chase it. He didn't need a grand telescope or a mountain of equations to start with, just the quiet courage to imagine what might happen if we took that constant speed seriously. The next time you see sunlight pooling on your pillow or a moonbeam slipping through your window, you can let yourself feel how miraculous it is that something so ordinary holds the keys to so many cosmic secrets. The light doesn't need you to understand every detail. It only asks that you remember it's always there, moving at the same pace, shaping the stage on which your dreams drift by. Out beyond your roof, stars send their beams toward you, some traveling for millions of years, never wavering from their loyal limit. Each ray tells you a story of the universe's patience, its cleverness, its gentle rules that bend but never break. Einstein's thought showed us that even time and space can be as soft and flexible as a dream, but the speed of light stands firm, an anchor in the drifting sea. So close your eyes, if you haven't already, and feel that quiet promise. The little beam keeps moving, exactly as fast as it should, carrying with it the shape of space-time, the dance of galaxies, and the soft hush of a mind that once wondered, what would it feel like to ride alongside a beam of light? Let it carry you too, as you drift deeper into sleep, traveling through the calm fabric of a universe that knows exactly how to keep its light steady and its dreams gently glowing. If you listen closely to the hush between the ticking of your clock and the distant hum of the night, you might sense that the beam you've been following carries a quiet authority with it. It isn't just a traveler moving at its favorite speed. It's the keeper of a limit that nothing in this vast universe can break. This speed isn't a suggestion or a polite guideline. It is the ultimate rule that everything else must obey. It is a boundary woven into the fabric of reality itself. Out there, in the endless stretch between galaxies, the universe is like a wide, calm sea. Stars drift like lanterns on a black ocean, each one pouring out light that ripples through the dark. Every single ray that leaves a star carries the same promise. It will move exactly as fast as the laws of nature allow, never more, never less. And everything that tries to chase that beam, every speck of dust, every charged particle, every ship we might dream up in the far future, will always find this barrier standing firm in its path. Imagine that you could build the fastest spaceship ever dreamed of, a silver arrow stitched together by the cleverest minds, powered by engines that never run dry. You and your fellow travelers strap in and launch into the void, faster and faster, chasing starlight across the black. Your engines roar. Your windows vibrate with the rush of speed. You push closer and closer to that sacred number, 299.92 kilometers each second. But no matter how much energy you pour in, you can never quite reach the beam ahead of you. You could spend all the fuel in the universe, and still the light stays just out of reach. It is not because the light is fleeing you. It is because nature has set the limit where energy, mass, and motion collide. The faster you try to go, the heavier you become. Your ship's mass grows in the strange math of relativity, demanding more and more energy just to push you a tiny bit faster. By the time you inch near that ultimate speed, it would take an infinite well of energy to cross the line, a bottomless pit of fuel that no star could ever supply. In this way, the universe protects itself from chaos. If things could move faster than light, cause and effect would twist and knot in ways that break the calm flow of time. Events might happen out of order. A message could arrive before it was ever sent. A star's light could reach your eyes before the star was even born. In this tangled mess, Reality would be impossible to untangle, like trying to read a book where all the pages have been scrambled into nonsense. But light's speed limit keeps the pages in order. It keeps tomorrow from arriving before today is finished. It makes sure that signals, thoughts, and actions unfold in a sequence that we can follow, no matter how far we drift from home. This boundary is not a prison. It is a promise that the universe will remain gentle enough to understand, even when its mysteries run deeper than sleep. Think about the starlight that touches your window tonight. It has traveled across the void for hundreds, thousands, even millions of years, never wavering from its speed. It left its home when our ancestors were still learning to shape fire into lanterns. It crossed fields of drifting dust, slipped past planets that had no names yet, and found its way to you, lying warm under your blankets. This ancient glow could never arrive sooner than it should, nor could it linger behind. It arrives at the perfect moment, honoring the cosmic limit that keeps the world in its rightful shape. Sometimes, people wonder if this speed limit makes the universe feel small or confining. But drift deeper, and you see how it does the opposite. It stitches meaning into distances that would otherwise be too vast to imagine. When we say a galaxy is millions of light years away, we are really saying its light has been traveling at the maximum allowed speed for millions of years just to reach our waiting eyes. Every night, sky is a library of ancient messages, each beam a page that the universe has carefully preserved for us to read. There is a hidden comfort in knowing that we can never catch up to these beams. Their speed ties the present to the past, and the past to the far future. It keeps the story of the cosmos spread out in a way that lets us glimpse what came before and dream of what might come next. Without this limit, starlight would arrive all at once, a blinding flood of information with no story, no sequence, no sense of time at all. You can also imagine how this limit shapes the small, familiar pieces of your life. Inside the circuits of your phone, tiny signals of electricity move at speeds that come close, but never equal, to light's perfect pace. They carry your words across oceans through fiber optic cables, bouncing in pulses that travel at the edge of this cosmic speed. The GPS satellites overhead keep track of your place on Earth by measuring how long it takes for light's signal to whisper from the sky to the palm of your hand. If the limit were not there, these signals would be unreliable, chaotic, impossible to predict. The gentle firmness of this boundary gives our modern world its steady heartbeat. In a sense, every time you turn on a lamp or light a candle, you become part of this ancient agreement. You invite these tiny travelers to slip free from their source and set off at the only speed they know. You trust them to arrive when they should, to bounce off walls, to brush your skin, to reflect back into your eyes, carrying color and warmth and the shape of everything you love. They do so without complaint, never breaking the cosmic law that has guided them since before Earth had oceans or forests to illuminate. If you listen closely, you might almost hear this limit whispering through the hush of your room. It is there in the steady tick of your clock, in the hum of distant streetlights, in the pale glow of the moon's reflected rays. It says, "Here is a boundary that protects you from a world that could be chaos. Here is a measure that keeps time gentle and space reliable. Here is a speed that nothing can surpass, not even in your wildest dream. And yet, dreams can carry you close. In your mind's eye, you can drift alongside the beam, Feel the rush of space folding around you. Watch the stars blur into lines of silver. But even in your imagination, the limit holds. You do not break it. You dance at its edge, savoring the way it shapes the vastness into something your heart can hold. So let this thought cradle you as sleep draws nearer. Light speed is not just a barrier, but a gift. It brings order to the starlit chaos, weaving a pattern you can follow, one beam at a time. It tells you that no matter how far you wander in your dreams, the universe has set gentle walls to keep the story whole. Drift deeper now, with the steady glow always just ahead, your constant companion always exactly as fast as it should be. If you follow that beam farther, you begin to sense that its steady pace is more than just a limit on how fast things can move. It also reaches into the hidden workings of time itself. The idea that time can bend and stretch sounds like something pulled from a dream, but it's one of those quiet truths that hums behind the scenes of every star, every planet, every breath you take. Long ago, people thought of time as an endless river flowing smoothly in one direction. No matter where you were or what you did, the river carried you forward at the same rate as everyone else. But when the stubborn little beam revealed its unbreakable speed, the universe whispered that the river isn't so simple after all. If you move fast enough, truly fast, close to the speed of light, the river slows down just for you. Picture two friends standing beside the tracks of an old railway station. One climbs aboard a train, an imaginary train that can travel almost as fast as a beam of light itself. The other stays behind, waving from the platform. As the train races away, the friend on board watches the world blur by. Inside the train, the clock on the wall ticks gently, marking each second as it always has. The passenger's heart beats, thoughts drift, dreams stir, all at their familiar pace. But back on the platform, the friend waiting sees something strange. From their perspective, the clock inside the train runs more slowly. The seconds stretch out. The heartbeat drifts to a lazy rhythm. The entire life inside that speeding carriage lingers, while the rest of the world moves on. Time, it turns out, is not an absolute master ticking away identically for all. It's a quiet companion, willing to stretch or shrink, depending on how fast you push yourself through space. This effect, which scientists call time dilation, is not just an idea scribbled in a notebook. It has been tested and measured, not with imaginary trains, but with particles racing through massive machines, with astronauts orbiting Earth at breathtaking speeds. Tiny, unstable particles called muons, born high in the atmosphere when cosmic rays strike, should decay long before they reach the ground. Yet because they move so quickly, their inner clocks slow down, and they survive the journey, arriving where they shouldn't be able to. Time has given them a longer lease because of their incredible speed. Or think about the satellites drifting far above your head, sending signals that help your phone find your place on a map. These satellites move fast enough and float far enough from Earth's gravity that the clocks inside them tick at a slightly different rate than the clocks on Earth. If we didn't account for these tiny shifts, a few billionths of a second each day, our navigation systems would drift, sending us miles off course. A tiny echo of time's slipperiness, corrected each moment by careful minds who understand the beam's quiet rule. All of this stems from the same simple truth. The speed of light is constant, and the universe bends its rules around that constant to keep things balanced. When you approach that speed, time must stretch to protect the limit. It's not a punishment, but a gentle agreement, an invisible handshake between motion and the ticking of the universe's clocks. There's something strangely comforting about this, too. You can imagine a world where time is fragile, breaking whenever something moved too quickly. But here, it bends instead of breaking. It flexes like a branch in the wind, resilient and patient. The faster you travel, the more the branch bows, until at light speed itself, time stops entirely for that beam. From the photon's point of view, if it could have one, the entire journey from a star's core to your eye happens in an instant, a single step across the dark. People sometimes wonder what this means for us, stuck as we are at everyday speeds. We walk, drive, fly, but we never feel time shift beneath our feet. We are too slow to taste it, and yet it's always there, waiting at the edge of possibility. In theory, if you could travel close enough to the speed of light, you could take a trip across the stars and return to find that decades or centuries had passed for everyone else, while only a few years slipped by for you. The past, the present, the future. They become threads you can stretch and tangle in ways that feel like a dream more than a law of physics. In stories and old fables, humans have always played with time. Tales of long sleep, of travelers waking centuries later, of clocks that freeze moments in amber. But the truth is even more poetic than the stories. It's not magic that bends time. It's motion, the simple, unstoppable push through space at speeds so great that the universe must pause and adjust the flow of seconds just to keep its balance. Think of that next time you see a jet carving white trails across the sky, or a train disappearing into the horizon. Even in these slow, human machines, the principle holds. The faster you go, the more you ask time to stretch for you. We cannot push ourselves anywhere near the beam's pace yet, but the rule is waiting, patient as ever, should we ever find a way. So the beam is more than just light illuminating the world. It's a measure of how deeply connected everything is. Motion and time, space and speed, the tick of your pulse and the swirl of distant galaxies. Each piece affects the other, woven together by this constant, this cosmic agreement that the beam will always move at its perfect pace, and time will bend around it as needed. Somewhere in the hush of your room, a small lamp might cast a soft glow against the wall. That glow is built from countless photons, each one born at the speed limit, each one indifferent to the clock ticking beside you. And somewhere far above, the starlight pooling into your eyes tonight is ancient, frozen in its own instant, carrying memories from a past that time itself could not hurry or delay. In this quiet way, the beam shows you that time is not something you can hold in your hands. It flows and twists with your motion, always shaped by the same rule that keeps the universe steady. The beam does not fret about how long its journey will take. It simply moves, with time slipping around it like a soft current around a steady rock in a river. The next time you wonder where the hours go, or why some moments feel so long while others vanish in a heartbeat, you might remember that time itself is never quite as rigid as it seems. It's just waiting to bend, patiently, gently, always in service to the tiny beam that taught us how the universe keeps its deepest promise. When you picture the beam of light slipping through the dark, you might think only of its speed or the way it shapes time. But there's another piece of its quiet magic: the way it gently tugs at the very fabric of space. For as long as people have wondered about the heavens, they pictured space as something fixed, a blank canvas that holds the stars and planets in place. But the beam tells us that space is not so stiff and unchanging. It can flex and fold, shrink and stretch, all to protect the limit that light carries within it. Imagine you're back on that speeding train again, racing toward the far horizon at nearly the speed of light. Inside the train car, you feel the steady hum beneath your feet, the low rattle of wheels on rails, the gentle sway of motion. To you, the length of the car is just what it's always been, a few strides from one end to the other. But for someone standing outside, watching you rush past in a blur, the train itself seems to compress, shrinking in the direction it travels. The faster you go, the more the length contracts, squeezed by the strange logic that the beam of light demands. This quiet twist of reality is called length contraction. It sounds like something out of a dream, objects changing their size just because they move quickly enough. But it is as real as the slowing of time. The universe bends space the way it bends seconds, stretching and squeezing to keep that stubborn beam's speed the same for everyone, no matter how fast they chase it. The closer your train gets to the speed of light, the more the space in front of you flattens, pulling the distance tight like fabric drawn taut. To you, peering out the window, the stars ahead rush closer, the miles between shrinking as your speed climbs. You could imagine this effect stretching to its ultimate conclusion. If you somehow reached the speed of light itself, something no massive object could ever do, the space ahead would vanish altogether. The journey would be instant, a single breath across the void. But this is a path only the beam can take. It alone can glide through space at that limit, untouched by mass, always moving at the perfect pace. For everything else, every ship, every particle with even the tiniest hint of mass, the fabric of space must shift instead, adjusting itself to keep the cosmic promise intact. No matter how much you dream of squeezing more distance into your stride, you will find the universe pressing back, reminding you that the speed limit is not just about motion. It is about how space itself holds together. It helps to think of space not as an empty room, but as something alive, something that can bend and flow when the moment demands it. Einstein's gentle equations showed us that this fabric is not rigid or brittle. It is flexible, shaped by mass and energy and speed. It can warp around planets and stars, creating the orbits that guide Earth around the Sun and the Moon around Earth. And when you move fast enough, it can draw the distance close to keep the beam's limit unbroken. You've already seen this bending at work in the world around you, whether you knew its name or not. Think of the way gravity pulls on starlight, bending the path of beams around massive bodies like the sun. During a solar eclipse, when the moon hides the sun's glare, astronomers have watched distant starlight curve around the sun's edge, a soft arc where straight lines should be. That graceful bend is space flexing under the weight of the sun's mass, the same way it flexes for speed. Or think of the black holes scattered through the universe, invisible wells where space folds in on itself so tightly that even the stubborn little beam can't escape. Near their event horizons, Space and time twist into strange shapes, the rules pushed to their limits, yet always faithful to the same cosmic agreement that keeps the speed of light exactly as it should be. Closer to home, these effects are so faint that you don't notice them in daily life. You walk to the corner store, drive to the next town, fly across an ocean, and never feel the length of your road contract beneath your feet. You live comfortably at speeds that make the universe's secret flexibility unnecessary. But the moment you step into the realm of beams and particles and satellites dancing at a fraction of light's speed, this hidden truth begins to shimmer into view. Inside giant accelerators, scientists push tiny particles to incredible speeds, brushing the edge of the beam's domain. There, distances shrink, lifetimes stretch, and space itself behaves more like a gentle wave than a fixed stage. These experiments don't just prove old theories, they reveal, again and again, how faithful the universe is to the beam's constant limit. They show that space and time are not prisoners of our ordinary senses. They are partners in a cosmic dance, weaving around each other to protect a simple rule. If you wanted to dream even bigger, you might imagine what this means for the far future. One day, when ships cross the solar system not in years, but in weeks, when explorers ride engines that brush closer and closer to light's speed, they will find their journeys growing stranger than any map can predict. Space ahead will flatten. Distances that once seemed hopelessly wide will narrow, and time inside those ships will tick along at its own peculiar pace. But no matter how clever the engine, how polished the hull, how brave the travelers, the beam will remain just out of reach. Its limit is not there to mock us or to taunt us, but to keep the universe from unraveling at its seams. It holds the shape of reality steady, so that the stars can burn in their rightful places, so that galaxies can swirl in graceful spirals, so that the light we see carries the true shape of what is out there. Next time you look at a single spark, a candle's flame flickering, a flashlight beam cutting through the dark, you might picture all this hidden shifting beneath its glow. Each photon leaves its source at the same unwavering pace, slipping through a fabric that flexes and folds around it, bending time and space in the quietest way. It asks nothing from you in return, but a moment of wonder. How can something so constant demand so much flexibility from the world around it? The beam doesn't need to explain. It simply moves forward, hugging its limit as tightly as the universe allows. And in that loyal journey, it reveals a secret that holds the cosmos together. That space is not a rigid void, but a patient companion, willing to stretch and squeeze so that the speed of light remains the same, the heartbeat of everything that glows. By now, you can see how the quiet little beam shapes not just what we see, but how we move, how we measure, how we understand the very stage we stand on. Its loyal speed limit bends time and space to keep its promise. But there is one more piece in this hidden puzzle: the way energy and mass join the dance. This part of the story might feel heavier in the mind, but its truth is as simple as a stone dropped into a pond, rippling outward, changing everything it touches. When Einstein scribbled his thoughts about chasing a beam of light, he found that the universe demanded an elegant balance. The faster you move, the more time must bend, the more space must stretch. But he also saw something even more surprising, waiting like a treasure buried in his equations: the bond between energy and mass. The idea was there all along, hidden in plain sight. When you push something to move, you give it energy. That energy is not separate from what the object is. It becomes part of its very being. And when you move faster, closer to the beam's limit, that extra energy makes you heavier, harder to push, more resistant to any more speed. It's like rolling a snowball through fresh powder. Each turn gathers more snow, making the ball bigger and heavier with every push. At first, you can move it easily, but as it grows, each shove demands more strength. Near the beam's speed, the snowball becomes impossibly massive, an unyielding mound that no amount of force can roll any faster. This idea lives inside the famous equation you've likely heard before, even if you've never really sat with its meaning. E equals mc squared. A small, neat formula, but inside it is the hush of the beam, the bend of space, the stretch of time, and the promise that mass and energy are not separate kingdoms, but two sides of the same coin. E is energy, m is mass, and c, the speed of light, stands there squared, a reminder that the tiny beam's speed limit gives this bond its scale. It's not a slow trickle of exchange, it's a flood, because c squared is a gigantic number. This means that even a small bit of mass holds a vast reservoir of energy, waiting to be unlocked. You can see this truth in the sun's glow. Deep in its core, hydrogen atoms fuse, and in that fusion, a tiny amount of mass turns into a staggering burst of energy. That energy races outward as heat and light, traveling at the beam's loyal speed, crossing millions of kilometers before spilling into your backyard, onto your face, across fields and forests. The warmth you feel on your skin is the soft kiss of mass turned into light, guided by the beam's limit. We see this bond, too, in the strange power that split the atom. When people learned how to unlock the energy packed into the nucleus of certain elements, they released a force that could light cities or level them. A single handful of matter, converted fully to energy, holds enough to power entire regions for years. E equals mc squared is not just a line in a textbook. It's a key that opens both creation and destruction. But for all its fearsome potential, the principle itself is not something to fear. It is a promise that everything is connected. Your body, the heat of your breath, the beams of sunlight that warm your pillow. Mass is frozen energy. Energy is freed mass, and the speed of light squared stands as the bridge between them. The beam does not hoard this secret. It demonstrates it every moment by carrying energy from the stars to your eyes. In a way, the universe has chosen this limit to keep the balance. If you push a particle faster and faster, feeding it more energy, its mass grows alongside it. Near the beam's speed, the energy needed to go just a tiny bit faster grows beyond measure. No matter how much you pump in, the beam remains ahead, calmly out of reach. It's as if the universe gently says, "That's enough." The energy and mass keep each other in check, so the speed limit stands unbroken. Think of the vast particle accelerators buried beneath the Earth, giant rings where tiny particles are hurled around at speeds brushing up against the speed of light. Inside, protons race around and around, heavier than they were at rest, their mass swollen by the energy of motion. Each extra push requires more power than the last. It's a practical reminder that the beam's limit is not just a theoretical line, but an impenetrable wall woven into how energy and mass relate. In your daily life, this principle hums quietly in the background. The warmth of a cup of tea, the fire that crackles in a hearth, the beating of your heart. Each draws on energy stored in the food you eat, the oxygen you breathe, the quiet fusion of elements that happens far beyond your reach. Every spark of motion and warmth obeys the bond Einstein revealed, and at its center stands the small, unwavering beam, speed squared into the heart of the equation. If you were to shrink yourself down to the scale of atoms, you'd see how this truth holds everything together. Electrons bound to nuclei, vibrations of molecules, the dance of particles in the air you breathe. All these are exchanges of energy and mass, all held steady by the speed limit that says, "This is how fast light must travel, no more, no less." It is remarkable, in its own soft way, that this universal limit does not feel like a barrier in your life. You walk across a room without thinking of the mass-energy equation. You warm your hands by a lamp without worrying about how many atoms fused in the sun to make that light. But every moment, this truth is there. The beam's limit shapes how much energy you can release, how much mass you can gather, how time and space bend to keep everything stitched together. One day, perhaps, humanity will find new ways to use this deep connection. We might learn to harness it with more care, more wisdom. We might send ships to the stars, guided by engines that sip energy from mass, riding close to the edge of the beam's constant speed. But even then, the limit will remain, not to mock our dreams, but to remind us that balance keeps the cosmos whole. So when you see the sunlight drifting through your window, or feel the warmth of a simple bulb above your head, you are feeling the hidden bond between mass and energy, a bond held steady by the same speed limit that carries the beam through endless space. It is there in every spark, every flame, every quiet glow, the hush of the universe, whispering that even the smallest things are more connected than they seem. Out of all the tiny travelers in this vast universe, the ones that seem to carry the most delicate secret about the speed limit are the photons themselves, the quiet specks of light that stitch everything together. Each one is born already moving at the maximum pace the cosmos allows, right from its very first moment. Unlike a stone you can throw harder, or a rocket that must build its speed over time, the photon has no gentle start or steady acceleration. It simply appears at the limit, carrying the perfect balance of energy and motion, ready to slip through the fabric of space without ever slowing down or speeding up. Imagine a photon leaving the surface of the sun. Deep in the star's core, it starts as something else, an energy change, a jostling of particles in unimaginable heat and pressure. One tiny piece of mass transforms, a bit of matter turns into pure energy, and out of that exchange, a photon emerges, a new spark added to the endless flow of light. But its path is far from straightforward. For thousands of years, it bounces and scatters through the dense layers of the sun's interior, rebounding from one atom to another, each step a small puzzle piece in its eventual escape. When at last it breaks free of the surface, the photon shoots outward into the empty dark, a patient traveler that will never stop until something catches it. Maybe it will brush past Earth, slip into a plant's leaf, strike a raindrop, warm your face on a winter morning. Or maybe it will sail on for millions of years, carrying the memory of the sun that birthed it to places no eye will ever see. What makes the photon unique is that it exists only at the limit. It doesn't have a choice to go slower. If you could somehow nudge it to ease back, it would no longer be a photon at all. Its identity is tied to its speed. It has no rest mass. It can't linger or idle or drift lazily through the void. Its energy, its very existence, is wrapped around the fact that it always moves exactly as fast as the universe allows. This is part of the reason light feels so different from everything else you know. A ball tossed through the air slows down eventually, tugged by friction, pulled to the ground by gravity. A train must brake at the end of the tracks. But the photon glides on forever unless something absorbs it. There is nothing to push against in the emptiness of space. No invisible wind, no cosmic drag. The beam slips along its path with perfect efficiency, honoring the limit that gives it life. Sometimes people wonder why light never loses its speed as it moves. How does a photon not get tired? But the photon has no clock inside it, no sense of time passing the way we feel seconds and hours. From its perspective, if such a tiny flicker could hold a perspective, the journey from its birth to its end is instantaneous. It leaves the sun's surface and arrives at your skin in the same breath, the same moment. Meanwhile, for us, that journey takes about 8 minutes. Time for a photon is always now. This strange fact is what makes the photon such a powerful messenger. It is a package of energy wrapped in motion, and it will deliver its message with perfect faithfulness, whether the destination is a blade of grass, an old telescope on a mountaintop, or the back of your eye. Every color you see, every shadow you notice, every glint of starlight in a puddle is the work of countless photons arriving exactly when they must. Their loyalty holds the entire visible universe together. They carry the warmth that makes seeds sprout in the spring and the signals that bounce through the fiber optic cables beneath our cities. They power photosynthesis. They feed the glow in your screen as you read this. They even keep our understanding of faraway galaxies alive, slipping through the dark with old stories about how stars once burned or exploded or faded away. If you could shrink down to the size of a photon, you would find that the ordinary rules no longer apply. No ticking heartbeat, no aging, no lingering moments of waiting. There is no halfway or almost for these little speedsters. They exist fully at the edge of possibility, moving with the pure, simple trust that the universe will always hold its speed limit steady. You can also imagine the other beams that travel alongside them. Neutrinos, those ghost-like particles that pour out of the sun in countless numbers, come close to the speed of light, but cannot quite match it because they have a whisper of mass. They slip through you by the trillions every second, so small and so indifferent that they barely interact with the matter of your body or the air around you. But they still bow to the same limit, coming as close as they can, yet never crossing the final line. In this way, the photon reminds us that the limit is not a fence built to trap us, but a perfect line drawn to keep the cosmos balanced. If the photon could choose to slow down or speed up, the careful dance of energy and matter would unravel. Heat would drift aimlessly instead of warming your skin. Stars would not shine the way they do. Colors would blur into confusion. The beam's constant pace makes everything else reliable. Sometimes you see this trust at work in the simplest ways. A laser pointer dancing across a wall, a rainbow spread through a prism, the shimmer of light bouncing off a river at dusk. Each gleam is a testament to the speedsters that carry light's energy across space and into your waiting eyes. They do it effortlessly, endlessly, without any fuel to burn, without ever needing to rest. There is something soothing about this kind of certainty. In a world that changes with every breath, seasons shift, storms roll through, people come and go, these tiny travelers stay faithful to the cosmic promise they were born with. They slip through the dark at the only pace they know, weaving warmth and sight and memory into the fabric of your days. If you could listen closely enough, you might almost hear their message. We are the light that holds the darkness at bay, the gentle speed that ties energy and time together, the hush of the universe moving at its limit. And we will keep moving, one photon at a time, until something welcomes us home. It's tempting, once you understand how tightly the beam holds its speed limit, to wonder what would happen if that rule could be broken. What if light did not have a final line drawn across the universe? What if photons could speed up, racing beyond the familiar number you know by heart? Would the world be freer? Or would it become a puzzle with too many missing pieces to ever put back together? Imagine, for a moment, a universe where light's pace could be pushed faster and faster, like a car that never hits the red line. A star might pour out beams that raced each other across the cosmos, some quick, some quicker, some so impossibly fast they'd arrive before they even left. Signals could leap between planets in less than no time, carrying whispers of conversations before they were spoken. At first glance, this might sound like freedom. Think of explorers who could hop from one side of the galaxy to the other without waiting centuries for news or company. Think of messages that would not lag behind rockets or satellites. You could call a friend on a distant world and hear their answer before you even asked the question. But peel back this dream, and you find a world where cause and effect begin to unravel. In our universe, the speed limit keeps time flowing gently forward. It guarantees that when you see a star's light, you are looking into the past, a clear, ordered past, each photon carrying the story of what was. If light could break its limit, that order would tangle. A star might flicker in your sky long before it ever formed. Galaxies could appear to shine and fade at random. Shadows could arrive before the glow that casts them. Even on Earth, the gentle logic you trust would splinter. Imagine you turn on a lamp and its glow spreads through the room faster than the moment your hand flipped the switch. A ripple of light and darkness out of sync, like pages of a book being read backward and forward at once. Shadows would dance ahead of their sources. Reflections would appear before the thing that reflects them. These gentle impossibilities would create not freedom, but chaos. Physics would lose its anchor. If particles could exceed the beam's pace, they could carry information that breaks the natural flow of cause and effect. Some scientists have played with this idea, imagining hypothetical particles called tachyons, speedsters that exist only beyond light's limit. On paper, they slip backward through time, delivering signals that twist logic into knots. But they remain theory, the stuff of thought experiments and gentle debates, because the universe has never revealed a single sign of these rebellious travelers. If they did exist, reality itself would be a hall of mirrors. You might see ripples of your own future brushing past you, events happening out of order. The bond between past, present, and future would stretch thin, snapping the thread of predictability that lets stars burn, planets orbit, and life unfold. What's more, the math that describes energy and mass would lose its balance. E equals mc squared depends on the beam's limit standing firm. Take that limit away, and the equation breaks. The connection between matter and energy would loosen. Stars might burn too quickly or fail to shine at all. The sun's steady glow could sputter into chaos. Entire galaxies might flicker like dying candles, unable to hold their shape. So the limit does not restrain us. It steadies us. It is the reason light arrives when it should, carrying stories from the past in tidy layers that make sense. It is the reason your eyes see the world in a sequence that lets you trust what happens next. It is the reason time moves gently forward, one heartbeat, one sunset, one flicker at a time. When you imagine breaking that rule, you see how the quiet beam holds more than just its speed. It holds the universe's promise that each step has a place. Without it, the night sky would be a blur of flickers, impossible to read, impossible to trust. The glow from a distant galaxy might leap ahead of its own creation, leaving you staring at echoes of things that never quite happened. In the end, the limit is not a locked door, but a gentle guide. It does not keep you from exploring the stars. It simply keeps the story of the stars readable. It ensures that when you look up at the dark, the light you see carries a memory that you can trust. The beam remains at its perfect pace, and in doing so, it gives the universe a shape that lets you wonder, dream, and believe that what you see is truly there. Once you've walked alongside the beam for a while, it's only natural for your mind to drift toward the horizon and ask the quiet question, what lies beyond the limit? If the speed of light is the final line drawn across the universe's map, is there any world, even a shadowy one, that might peek past it? It's here that the whispers of particles, more like ghosts than travelers, slip into the story. The so-called tachyons. They belong not to the sturdy world of proven science, but to the dreamlike realm of what if. In theory, a tachyon is a particle that never slows down to the speed of light, because it cannot. Its entire existence would unfold only beyond that final line, forever faster than any photon, always out of reach of the familiar. Imagine, if you like, a particle born already moving too fast to touch. If it ever fell back to the speed limit, if its feet touched the same ground as our steady beam, it would vanish, because the equations say such a thing cannot exist in both worlds. It either stays ahead, slipping past the beam before the beam even arrives, or it does not exist at all. The word tachyon comes from the Greek word for swift, and that is all it is, speed incarnate, woven from pure speculation and mathematics. Its story lives mostly in chalk dust on blackboards, pages in old physics journals, thought experiments traded over coffee in quiet corners of university libraries. No one has ever found a sign of one. No particle accelerator has glimpsed their trail. No signal from the depths of space has hinted that they race past the cosmic speed limit, while the rest of reality lingers behind. Still, they cling to our imagination because they show us what might happen if the rules we know bent just a little. In the realm of tachyons, time itself begins to tangle. A message sent by a tachyon might arrive before it was sent. A cause could ripple backward to its own beginning. The beam's limit would lose its authority, and the clean flow of events, the unfolding of the universe from one heartbeat to the next, would unravel. For some physicists, this gentle tangle is fascinating, if only because it reminds us how delicate the balance really is. Without the limit, the story falls apart. Without the beam's steady line, the math slips into chaos. Equations that hold stars in place break open like fragile eggs. The predictable dance of energy and mass, the dependable shape of time, the soft bend of space, all of it depends on that firm ceiling overhead. And yet, there are always hints at the edge. Sometimes, when we study the smallest pieces of the world, the quantum realm of particles and waves, we find ideas that brush right up against the boundary. Entangled particles that seem to share information instantly, no matter how far apart they drift. Virtual particles that pop in and out of existence, borrowing energy from nothing for a heartbeat before disappearing. These curious tricks tempt us to wonder, could something truly slip past the beam? But again and again, experiments tell us the same thing. The limit remains. Even entanglement, as slippery as it feels, does not allow signals to leap ahead of the speed of light. It hints at connections deeper than distance, but it does not break the beam's promise. It only deepens the mystery, showing that the limit is not a brittle shell, but a flexible seam, able to hold even the strangest puzzles together. If you stand back and look at the whole canvas, the possibility of tachyons becomes something more like a mirror than a window. It reflects what would happen if the anchor were pulled free. It shows us that the speed limit is not there to frustrate our dreams of going faster, but to keep the world's heartbeat calm, so every star's glow arrives when it should, every cause lines up before its effect, and every story makes sense from beginning to end. And so, these ghostly particles remain at the edges of our dreams, an echo of curiosity that reminds us the universe does not bend its rules lightly. The beam, loyal as ever, stays ahead of every hopeful chase, gliding through space at its perfect pace, never losing its way. It does not fear the thought of what might lie beyond, because its speed is not a prison. It is the shape of the path that holds everything steady. So, if you ever find yourself wondering what it would feel like to outrun light, to leave the beam behind and step into a world where the past and future fold into each other like a paper crane, you can smile at the thought. The limit holds. It holds so the stars burn as they should, so shadows stay behind the things that cast them, so your eyes see the true order of what was, what is, and what may come next. Even though the limit holds so quietly, so perfectly, people have never stopped trying to catch it in the act, to measure it more precisely, to nudge it with experiments that ask, could it ever slip? Every time someone aims a laser down a long corridor, launches a satellite into the sky, or times a distant star's flicker, they are putting the beam to the test, asking it to prove its loyalty one more time. You can trace these tests all the way back to the days when mirrors spun on brass wheels, bouncing beams down dark tunnels. In the 1800s, physicists like Fizeau and Foucault built clever devices that split a light beam in two, sent each piece along a separate path, and then reunited them to see if they matched. If the speed limit wavered, even for an instant, the returning beams would reveal it in tiny shifts, a ghost of interference patterns caught on a piece of glass or a bit of smoked paper. Each result said the same thing. The beam keeps its pace. As the tools grew sharper, so did the answers. Michelson's experiments, echoing through the halls of old observatories, nudged the measurement closer to the number we still carry in our minds today. 292,458 meters every second. A figure so precise it hums behind every GPS signal, every fiber optic cable, every data stream that jumps between continents in pulses of light. It didn't stop there. In the 20th century, we learned to bounce radar signals off the moon and watch them come home a few seconds later. We measured how the time it takes for light to return matches the distance so perfectly that the beam itself becomes a ruler, stretching from our backyard to the lunar surface and back. Each pulse returns exactly as the limit demands, never faster, never drifting ahead of its promise. And then there are the tests that drift into deeper space. Space probes ride sunlight across the dark, guided by the way light's speed shapes how long signals take to reach us. When Voyager slipped past the planets and drifted into the deep quiet between stars, we listened for its faint messages, each one carried by the beam, each one confirming that the speed limit holds even at the edge of our solar system. On Earth, scientists keep testing, pushing their instruments to greater precision. They cool clocks down to fractions of a degree above absolute zero, trap atoms in laser cages, and watch how time ticks when energy flows near the limit. They collide particles in giant accelerators, searching for any sign that something might dart ahead of the beam, even by the smallest whisper. Yet the answer remains. The limit is loyal. The limit's reliability shapes our everyday lives in ways that feel invisible but hold everything steady. Your phone's map app relies on satellites that beam signals down with breathtaking accuracy, each one measuring time and distance according to the beam's pace. Without the limit, the signals would drift, your position would slip, and your map would spin out of control. Even in the vast quiet of the universe, we use the limit as our yardstick. Astronomers read the faint glow from ancient galaxies, knowing how far that light has traveled at its constant pace. The age of the universe itself, billions of years unfolding in a gentle arc, is written in the speed of those beams. If the limit wavered, we would lose our measure. The past would dissolve into guesswork. Every test we run, every beam we bounce, every clock we compare, each one is a quiet conversation with the universe. Are you still holding steady? And each time, the answer returns in the hush of starlight and lasers and radar echoes. Yes, the beam moves at the only speed it knows, patient and constant, loyal to the rule that shapes reality's edge. So the next time you see the glint of a satellite crossing the dusk sky, or watch a storm flicker with lightning that lights up the world in an instant, you can remember that all this precision rests on something as soft and steady as the beam's limit. It is tested every day, and every day it holds, stitching together the map that lets you stand here, wondering about it at all. If you follow that tiny beam all the way to its final destination, you find that its story never really ends. A single photon may slip from a burning star, bounce off a moon's surface, glance past a drifting satellite, and finally brush against the back of your eye, its long journey ending in the spark that lets you see. Its limit never wavered. Its promise stayed true, no matter how many years or miles it crossed. All through the dark, this quiet speed limit has shaped every glow and shadow, every sunrise and distant galaxy. It ties time and space together with a single line that nothing can cross. It keeps the universe readable, a place where stars shine when they should, where echoes arrive when they're meant to, where the past reaches us at just the right moment. The next time you light a candle or look up at the night sky, you can remember that each flicker and glimmer is the same old story still unfolding. A beam moving exactly as fast as it must, carrying warmth, memory, and the soft hush of a rule that holds the cosmos steady. It's just a limit, and yet it is the reason you can see it all.